have discussed in the previous class. Okay, last time I think we have stopped until if you can turn to your textbook, we have discussed until if I'm not mistaken, that will be okay. Last time we stopped at, I forgot everything. I have prepared, but somehow the problem made me forgot everything. Okay, we have covered the questions on example 2.9. Okay, I did remember that I want to share how we can use the Excel in order to help us out with the calculation of the probability value. So I'm going to use the same exact example that using the Excel that will be for example 2.9. Okay, so if you look at my Excel now, can you see my Excel?
Yes.
Okay, thank you. Okay, now for 2.9, example 2.9, I believe this is the table that I'm referring to. Okay, now for example 2.9 just now, the question is about this one. So we are trying to, okay. Now we know that the probability, the x random variable is distributed with binomial and the number of trial is 12 and the probability of success is 0.10. Okay. By using that particular what we call value, okay, we go back to our Excel. Okay. So now there will be, if you can see here, there is two columns. There are two columns about the individual and cumulative. Okay, let me shade this with yellow. Okay, for this yellow means that if you look for exact probability value, if you have your x is equal to 0, then the probability of x is equal to 0 is this one. If the x is equal to 1, so probability of x equal to 1 will be this one. Okay, so what happened here, when we have cumulative, this cumulative is the one that we have in our cumulative table binomial. So means that this particular row, okay, this row is actually refers to our table, okay, where for this part, this is what we call px less than or equal to 0. This one is px less than or equal to 1. When I say less than or equal to 1 means that we are starting, we add the probability of x is equal to 0 plus px equal to 1. Whereas in this part, okay, this specifically for individual, it means that we are specifically talking about the exact value of the x. Okay, and here we have px is equal to 1. Okay, so that's why if you look at the difference between this row, okay, this standalone value, this one is the addition of the first and the second probability. So I hope you can understand that now in that sense. Okay, let us redo the calculation. How we can use the Excel in order to help us finding the probability value. Okay. Okay. I'm really sorry for Excel. I cannot use the eraser, so okay. I hope the error will not disturb you. Okay. So how we can use it? So you start with the equal sign, and then just type binom. So when you type the binom, there will be few what we call selection that you can have, okay? But usually for this one, we are going to use the first option. When we double click them, okay, what happened is that you will have the option to be what we call, there will be some values that you need to put in. Numbers will refers to the x value that you are referring to. So in that case, our x value is 0, which is at the A21. So we just type A21. So it will take the value of x is equal to 0, then put comma, and then we go back to the probability, our x random variable, the distribution, and we know the number of trial is 20, right? Sorry, 12. Okay, 12 for the number of trial, and the probability of success is 0.10. Okay, comma, and the last part is the one that, if you can see, you have two options, true and false. If you choose false, you will have your individual probability for each and x value that you are referring to, from x is equal to 0 until x is equal to 12. So let us try with the individual. That would be false. Just type in false and then put the bracket and then enter. Okay, so you will get your first value for the probability of x is equal to 0. Then you drag down. Okay, just drag. Why my mouse cannot use the track? Okay. Now drag the value downward. Then you see, means that from beginning from x is equal to 0, x is equal to 8, the probability value approaching 0 until you get the trial, the 12th trial, the probability is equal to 0. What happens if we use the cumulative, whereby we can have from our binomial, cumulative binomial probability distribution? So begin with equal and then binom, and then double click the binom Dist, and then you are referring to x equal to 0, then click the value, the column, the cell, and then put in all the number of trial, the probability value of success, and then type true. Okay, so the first number, the first probability value will is exactly the same as individual value. So drag downward until number 12, and if you can see, the reason why we have from 8 until 12 we get 0 is because when we add up until the 7th value, it's already 1. That's why the rest got 1 here, because this is just all the summation of all the probability values. So do you have any question here, class? Any question, class? Okay, so if you don't have any question, I will just go quickly. Let us continue with the what we call our slide. Okay, now when we stopped last time, we have finished until example 2.9, and then we have what we call exercise. Okay, so that exercise is on page 51. Can you all turn your textbook on page 51? Okay, so let us try this question before we move to the where the situation of our probability of success if is greater than 0.5. Okay, let's just do it this together. Now, a missile guidance system has 5 fail-safe components. Okay, so we are talking about missile guidance. Okay, and this missile guidance has 5 fail-safe components. So all the words given in your question will be a hint for you to find your answer. So for every value that you have in your equations, you should give your attention to it. Which of the value will be very useful for you to solve your equations, okay? Now, the probability of each failing is 0.05. Now, this is what I meant last time. Sometimes the probability of success is considered as the failure. So in this case, the success is the failure. So this is what I meant just in my first lecture. Okay, so when we are talking about probability of success for binomial, the probability of success could be referring to the probability of failure. Okay, now the probability of failure is 0.05. Find these probabilities and interpret your answer. So now before we can start, okay, okay, as usual, we are going to interpret what will be our random variable or our x here. So what can you guess from our x given in the questions? Class, someone? It should begin with the number. The number of what? The number of class?
Missile falling.
Missile falling. Okay, that falling terms is what in your questions? So if possible, refer to the terms used in the questions. The number of failing, right? Failing missile guidance. Okay. Now, chapter 2 class require your meticulous work. Okay. So it will require you to understand the concept, and you will have to note down what we are not talking about the perfect terms that we wish you can highlight, but at least you can get the whole idea of what is the random variable refers to. Okay, so in this case, the number of failing missile guidance system. Okay, and from the given information, we know this is our P. Okay, what will be our N in this case, class? What will be our N? What will be the rest, the other number that you have in your equations? You have 5, right? So this is your N. So in this case, we know that X is binomially distributed with the number of trial 5, and the probability of success is 0.05. Okay, everyone got that? Okay, now okay, let us begin with the Excel, by using the Excel. Now, having said that, we know that X is binomially distributed with the number of trial 5 and probability of success is 0.05. Now, if let's say I just make it simple for you. Now, I have my Excel value. Now, in my Excel value, I have my individual. So not cumulative means this is an individual value. Okay, and we have what we call cumulative. This is what referring to our table of binomial. Okay, now let us see how we can solve the equation if you are using your Excel. Let's say you get this Excel on your own. Now, find the probability that exactly 2 fails. Okay, now we know that X refers to missile guidance which fails. Okay, so if V refers to this particular table, Px is equal to, definitely is given by what? 0.2143. Is it correct? Isn't it correct? If let's say we use our Excel table. Everyone agree with me?
Yes.
Okay, now, what if, let's say question number 2. Are you all okay? I'm using my red pen. Or you wish to have black pen? because I'm giving you the slide afterwards, right? So I'm not sure whether the red pen will be okay to you. So do you prefer red pen or blue or black?
Okay, madam.
Right. Okay.
Okay, okay. Okay then. Okay. Let us move to question number 2. Okay. More than 2 fill. So we have definitely x more than 2. This is how we can denote that in terms of mathematical function. So remember the terms if we have all from 0 until 5. So if you are talking about 0, 1, 2, greater than 2 will be 3 and above. Okay, so we know the whole thing here, the probability is 1. So in order for to find this shaded area, this will be 1 minus p x less than or equal to 2. Okay, so in this case, it would be 1 minus less than or equal to 2, means that we are going to take 0, 1, 2 minus 0 0.20. Okay, so you will begin from 0.77378 plus 0.20363 plus 0.02143. Okay, let us use the second one. Okay, so the second one, so the first one will be the same as this one. So the second one will be px greater than 2 is equal to 1 minus px less than or equal to 2. So this one is much easier. So we'll just look for 2. 1 minus 0.99884. So this will be what? You got the answer here, right? So it's about 0.0012. So the same here, it will be 0.0012. Okay, now the question asks you to interpret. How do we interpret in this case? Now, when we interpret our what we call our probability value, so we will have to multiply by 100. So in this case, okay, multiply by 100, you will get 0.12%. Okay, so how are we going to interpret? So there will be basically there will be two ways on how you can interpret the probability. So the first one would be, okay, in terms of chance. You can interpret in terms of how much the chance for that particular event to occur, or whether you are going to use likely, unlikely, impossible, or possible. So you can use different terms in terms of how you can interpret your probability value. So let's say for this 0.12, okay, so in terms of chance, I would say there is 0.12%, or you can say 0% chance that more than 2 missile guidance system will fail. So this is how we can interpret. Okay, the other one in terms of not talking about chance, okay, you can also, okay, let's say in this one you will get 0.12%. Okay, you can say because this is the probability is near to 0, so you can say it is unlikely. It is unlikely that more than 2 missile guidance system will fail. Okay, so remember class, this is how you can interpret your probability value. The less the number, the less the possibility it will occur. The higher the value approaching 1, the higher the probability it will occur. Okay, so any question here, class? Because last time we didn't discuss on how to interpret the probability value. Okay, okay, is everyone okay? If okay, I'll just proceed with the third question. Okay.
Okay, madam.
Okay, so the third question, let's say the third question we are using the cumulative binomial table. Okay, so the third question, all will fail. Okay, probability all. So when we say all, so we need to check how many trials do we have. So if we have 5, then we are talking about x is equal to 5. Means that all 5 missile guardians will fail. So in this case, if you are using your binomial table, so you look at your probability of success 0.05, and then the number of trial is 5, and then look for 5. In this case, why 5 is not given is because 5 is already 1 here. Okay, so you have 5. So according to the concept that we have learned, when we wish to find exact value for 5 using the cumulative probability table, this will be px less than or equal to 5 minus px less than or equal to 4. That will be what? 1 minus 1, that will be 0. Now, is it correct? So let us move to the individual. Okay, if we look here, px, this one is px equal to 5. This one is px equal to 4. Okay, so this one is px less than or equal to 5. This one is px less than or equal to 4. So this one refers to what we have in the cumulative table. So it will exactly the same here. You will get 0. But for this cumulative, okay, okay, we don't need to discuss about this. I'm afraid some of you might get confused with it. Okay, so now how do we interpret this? So this one, unlike this one, it is unlikely. Okay, even though it's very small, we see just unlikely. So when we have exactly 0, what would be the suitable terms to use, class? In terms of likely, unlikely, class, or possible or impossible. How can someone try? Or you can try on your own. Just wonder, okay, what would be your answer to this probability value equal to 0? How do you interpret 0 here? Okay, if I simplify for you, it is impossible that all missile guidance system will fail. Okay, or you can say there is zero chance that all missile guidance system will fail. Okay, now what else did ask? Okay, the last question asks you compare the answer for part 1, 2, 3 and explain why these are reasonable these results are reasonable. So now the question asks you to make sense of what you have got from your calculation of the probability. For example, okay, you got exactly two missile guidance fail. The probability is 0.2143. So there will be 21 or 22% that exactly two missile guidance will fail. But when we say the more missile guidance fails, what happens? The probability becomes very small. And if we go to all missile guidance fails, the probability becomes 0. Can someone give some maybe like conclusion or what you can conclude from the three probability value? Class. So if you are talking about the first one, Px is equal to 2, the probability is 0.214. When you have x greater than 2, the probability getting smaller is 0.0012. Okay, and then when you have Px equal to 5, it becomes 0. Okay, so in this case, 21.4%. Here you have 0.12%. Here is 0%. Okay, so what can you conclude from here? All these are reasonable because we are talking about missile guidance system, which is very sensitive. It should have zero error. Okay, and when we are talking about the probability of failure, it should be very, very, very small failure. So in this case, as the number of failure system increases, the probability value decreases. Okay, as the number of missile guidance system failure increases, the probability of success decreases. So this will be your conclusion for question number 1. Okay, any question before we move to question 2? Class?
Madam,
Class, any question? Yes.
someone comment at the chat box.
Someone comments, so I need to stop. So this is why I'm not. I don't really keen of okay. Someone comment in the chat box. Doctor, can you repeat the binomial table? I can enable microphone. Okay, I'll repeat again at the binomial table part. Okay, present now. Entire screen. Share. Okay. For the binomial table, okay, let's say I repeat question 2. Okay, I repeat question 2. Question 2 asks, what if the probability of missile guidance fail is greater than 2? Now, if we are looking, if we are using our binomial table, now binomial table should always reflect this. It will always be this one. Because why? Because this is referring to Px less than or equal to 0. This one is referring to Px less than or equal to 1. We are talking about cumulative. Okay, that's why at the end of your column here, it become Px less than or equal to the number of trial that you have. Okay, so if I'm talking about 4, then we are talking about 4 trials. Okay, so if we are talking about actually from here lah, for 5 number of trial, probability of x, if we are talking about this probability of success 0.06, so this one is actually Px less than or equal to 0. This one is Px less than or equal to 1. Until the last number of trial, it should be 5 actually, but since you have already 1, that's why the 5 is not shown here, but it's actually 1 here. Okay, now that's why for the last part it is px less than or equal to 5, which reflect is actually px is equal to 0 plus px is equal to 1 until px equal to 5, which include all the component of individual probability. Now, if we are talking about question number 2, okay, now question number 2, we are talking about probability of greater than 2. Now, how many trials do you have? You have 5 trials. So, if let's say I put somewhere here, okay, from 0 success until 5 success here. Now, we are talking about 0, 1, 2, 3, 4, 5. Okay, now we are talking about more than 2. We are talking about 2 here, but more than 2 because 2 is not included. We don't have equality here. So, we are talking about more than 2, then we are referring to 3. That's why we are looking for the probability of this value actually, this region. Now, since our binomial table fulfills this criteria, that's why we have to change this into what we call following this. Okay, that's why we know that the total probability from 0 until 5 is 1. So, if we are looking for this one, now if we are looking for this answer, we can use this sign. How? By taking the whole probability 1 minus the probability of what? The probability of your x, which is less than or equal to, because we are talking about less than 3. So it will begin with 2, exactly with less than or equal to 2. That's why we have, to solve this equation, we have p x less, it will be 1 minus, okay, 1 minus px less than or equal to 2. That's why we transform this into this one by using the concept of this one, because we understand the concept of this one. Okay, I hope you understand by now. So how do we solve? Now we have 1 minus px less than or equal to 2. It will be this. Okay, am I referring to the correct? Okay, so it will be 1 minus 0.0.9988. So it will be 0.0012. Okay, so any question, any more question before we move to the second question? Okay, if no question, then we continue with the second question, which is much different from what we have in the first question. Now, a student takes a 20 question, true, false, exam and guesses on each question. Find the probability of passing if the lowest passing rate is 15 correct out of 20. Would you consider this event likely or unlikely to occur? Explain your answer. Now, sometimes in the question that you have, you will be given more numbers in your questions. So in order for you to identify which numbers that will be useful for your solution, so you have to understand what is given in your question. Okay, now is this a binomial? Definitely it's under binomial, but when you have your test, you will have to check on your own, because since we are talking about binomial, so all the examples are under binomial. But when you have your questions during your assessment, you will have question about poisson, question about binomial, question about normal distribution. So how are you going to identify which is which? Okay, so in this case, if let's say we are trying to figure out, does this, what we call questions, fulfill the binomial probability distribution? So we have 4 criteria, right? So what would be the criteria? We have the first one, n trial. So how many n trial? So in this case, you have how many trial? 20 trial. Okay. So the second one would be what? Probability of success. In this case, okay, when you know you have true false, okay, we know that there will be two outcomes, right? Definitely two outcomes only. True or false, correct or incorrect. Could be either one. Okay. The third one would be what? The probability of success. In this case, probability of success is what? If you're talking about is either true or false, is definitely is 0.5. Okay. And of course, when you answer from question 1, question 2, question 3 until the 20th questions, question 1 and question 2 will be independent to each other. Okay, so independent. Okay, so the probability of success also is what we call constant towards 20 questions. There will be no change in terms of the probability of success. Now, from here, let's begin with the interpretation of what will be your X. So what will be your X in this case, class? What will be it will always be the number. The number of what? The number of what? If you are talking about passing grade, is 15 out of 20. So you are talking about the number of what? Class. Can someone try? The number of? If you are talking about passing, are you going to talk about mistake, or are you talking about correct? Class? The number of mistake or the number of correct?
Sure.
The number of correct questions. Okay, so in this case, X will be binomially distributed with the number of trial 20 and the number of the probability of success is 0.5. Now, it seems easy because I assist you in terms of how to come up with the value, how to choose the value, what will be your X, how the X is distributed. So it seems a bit easy since we are doing the discussion. Okay, but somehow this kind of what we call understanding require you to do what we call a exercise. So I hope after we finish the binomial, all of you can start doing the what we call the tutorial questions. Okay, we are not going to we can't have what we call time to exactly discuss about the tutorial. So whenever you have any questions, you can ask during our lecture. Okay. Okay, now let's continue with this. Okay, now what is this for? Okay, now this one is actually from Excel, using Excel. I have two options. Since our time has been distracted by the problem earlier, which one do you choose? Do you choose using binomial table or Excel? Class? Class? Why don't we use binomial table? Huh? Use the binomial, okay?
Okay.
Class? Okay. Just use the binomial table, okay? Let's see. For those who do not know how to use binomial table, so you can look for the number of trial 20 and then look for the probability of success is 0.5. So look for any binomial that fulfill n trial 20 and probability of success 0.5. Now, what is the question? Find the probability of passing if the lowest passing rate is 15 correct out of 20. So how do you interpret that? Passing rate is 15 correct out of 20. So your X should be greater than, equal to, less than or equal to? Which one? Equal to, greater than, less than, or equal to? Which one, class? Look at the questions. The question should begin from here until here. Can someone try? A, B, C. Which one? No. A, B, or C?
C, C.
C. Why C? You're talking about 15 correct out of 20. Now look at the questions. The question says, is 15 correct? It does not say at most, at least. It says is. Your keyword is. So if is, then A is your option. Okay? Is it? No, wait. Is. Now, if is, now, let me correct. If only is, if is, means that out of 20, the passing mark, 15 is your keyword. Is it exactly? No. This is wrong. Okay? Find the probability of passing if the lowest passing rate is 15. So by right, this one cannot wrong because of course we are looking for greater than. So B also wrong. So it should be greater than or equal to. Because it should be if you correct 15 or 16 or 17 or 18 or 19 or 20, means that if you got any of this value, you will be considered as pass. Okay, but if we say 15 only, what about the rest? Whereas we have 20 questions. If you are talking exactly 15, it will be incorrect. Okay, so let us look. So let's say Px greater than or equal to 15. Okay, greater than or equal to 15 means that we are talking from 0 until 20. Now we are talking about 15, 14, 16. Now 15 and 15 is included. Okay, greater than or equal to 15. So now the whole probability is 1. So we can deduct from this particular region. Okay, we can deduct from this part. Deduct this part. Okay, so 1 minus Px less than or equal to 14 or 15 first. 14 or 15? Since 15 is included, then you are talking about 14. Okay, so then you will have for N20, look for 14. For N 0.05, so it would be 1 minus 0.9793. Can someone calculate that? Can someone calculate that? What is the value? Is it as given in the answer? 0.021. Is this correct? Class? Why everyone so quiet?
Yes.
Okay, now You have your answer 0.0207. So if you look at the answer, yes, it is 0.021 to 3 decimal point. Okay, now how do we interpret? Multiply by 100, so you will get 2.1%. So how do you interpret? There is 2% chance that the student there is 2% chance that the student what was the sentence just now? There is zero chance that all miss out. Okay, there is 2% chance that, what will be the sentence just now? Find the probability of passing with the lowest passing rate. Okay, there is 2% chance that the student will pass the exam or test, the exam. As simple as that. Okay? Okay, are you all understand? Okay. If you do you have any question before we proceed? We haven't discussed about poison, yeah? Okay. Okay, do you have any questions? If no, we proceed with the last part before we go into poison. Now, if you turn to your page on page 52, turn your textbook on page 52. I would like to simplify about this part. Okay, calculation using cumulative binomial probability distribution table for p greater than 0.05. Now, can you turn to your binomial table? Last page of your binomial table. Can you all do that, class? Binomial table. Last page, that will be on page what, class? Can someone tell me? Can someone tell me, class, which page, last page for binomial table? Class, turn to your binomial table at the back of your textbook. What will be the last page for binomial before poison? Someone, please. Are you all with me
205.
or? Okay, thank you. 205. Can you tell me what is the largest probability value given in your binomial table? Guys, look at your table. At page 205, look at the first and second row that contain the p value. What will be the largest p value that you have in the table? I just want to hear from you. What is the value of p? The largest p value given in the probability value?
0.5.
Yes, 0.5. Now, knowing that binomial table limited with the probability of success 0.5, there will be cases where the probability of success given will be greater than 0.5. So your textbook on page 52 is discussing about this one. So how are you going to solve a binomial problem where the probability of success is larger than what is available in your binomial table? Now, how are we going to do that? So I need to simplify the explanation. So I just jump straight away to the example of 2.10. Okay, so example of 2.10. according to the table provided by the US, or should I just go to the exercise because you have, it's okay lah, never mind, I just explain the example now. According to the table provided by the US National Center for Health Statistics in Vital Statistics of the United States, there is about 80% chance that a person aged 20 will be alive at age 65. Suppose 10 people at age 20 are selected at random. Let us attempt to use the cumulative binomial table to find the probability that at least 8 people will be alive at age 65. How do we know that this is binomial? Now, what will be the keyword that this is a binomial distribution? Now, we are talking about chance a person would be alive. A person would be alive at age 65. So we are talking about alive or death. Death. D-E-A-D. D-E-A-D. Alive or dead. Okay? So means that you are talking about two outcomes. It's either the person will alive or it will be dead. Okay? So now, two outcomes, the probability, what will be the probability? The probability of success is 0.8, and it will be constant across different what we call people. Okay, now what else do you have in your what we call in your question? Okay, other than P 0.8, we know that we are talking about life and death. And we are talking about, suppose 10 people. Now, this is your keyword. 10 people. At the age of 20, okay, at the age of 20 are selected at random. Means that you are now talking about your N is 10. Okay, so what will be the questions? Find the probability that at least 8 people will be alive at age 65. Now, I always like to highlight the questions because in the questions, it lies the keyword that you are going to use for your X random variable. Okay, so somewhere here, the X random variable is what we call is depicted. Okay, is illustrated, is actually in the questions. Now, how are we going to do that? Now, what will be your X? How do you define X? How do you define X? So, since we are talking about people will alive, what kind of people? People age 20 alive at age 65. So, X will be the number of people age 20 will be alive at age 65. So that will be your defined X. So how does the X distributed? X is distributed random binomially with number of trial 10 and probability of success is 0.8. Now, obviously 0.8 is larger than 0.5. So there will be a transformation or alteration that you need to do towards your X here. So I'm not going to explain in detail. So I just want to put it in simple way so that it will be easy for you to understand. But if you still don't understand, go back to page 52 and read it on your own. Okay. Now, since we have, it's just like the concept of we have the whole probability. So let's say from 0 until 10, the whole probability is 1. Now, if you are talking about 0.8, which is more or less is, let's say, is covering 0.8. Okay, then you have 0.2. The balance is 0.2. Now, how are we going to use this concept actually? Now, in order for you to transform that, okay, it's just the same, almost the same. It's just that you transform in terms of, just to give you a clearer picture, we choose instead of x, we transform that into y. So y is still binomially distributed. Now what happened in the trial and probability of success? Okay, so in this case, okay, okay, what happened is that when you transform, the number of trials still the same. You have 10 trials. But since we are going to look into our binomial table, the same binomial table that we looked before, so 1 minus 0.8 would be 0.2. Okay, in terms of what is y, so y in this case, okay, in this case, if you look on page 53, y is the number of people age 20 who will be dead, or you can say will not alive at age 25, the reverse of this one. Okay, so y is the reverse, So dot will not alive, or just simply say dead. Okay, now the question given in the original form is what we call at most, right? At least the symbol would be px greater than or equal to 8. Now, since we have number of trial, since we are using this concept, now this will be transformed into, okay, this will be transformed into p of y. If you have greater than, it will be less than. Less than what? 10 minus 8. Okay, because we are talking about the reverse. If we are talking about this one, then the reverse is this one. Okay, so this will be p of y less than or equal to 2. Okay, so directly from your table, okay, from your binomial table, okay, so you can check from your binomial table, it will give you 0.6778. Okay, so how do you interpret the probability of at least 8 people age 20 will be, so when you interpret, so go back to the interpretation that you are using it. Okay, so okay, directly use the original, what we call meaning of your X random variable. So the probability of at least 8 people age 20 will be alive at age 65 is 68%. Or you can say in precise 67.8%, or just approximate to 68%. Okay, so that's how we solve if you have p greater than 0.5. Now class, poisson will be a bit simple. So do you want me to discuss one of the question in the exercise, or we just go to the what we call poisson? Class, give me your opinion. Hello. Class, you want to discuss exercise, or straight we go to the next part? Are you all disconnecting with me?
Discuss the exercise, madam.
Discuss, okay.
Yeah.
So if we discuss, I'll just choose one question. Do you want first question or second question?
Second, madam.
Second, okay. Second question, okay, now. So I hope this one you can try, yeah? Try it on your own. Okay, try this one. Now, in a survey, 55% Malaysian adults said that they never heard of the Internet of Things, IoT. If 20 Malaysian adults are selected at random, find and interpret the probability that less than 12 will say they have never heard of IoT. So, obviously, this will be your
Madam, you are not sharing the
Madam,
slide.
sharing.
Oh, sorry. So old already, yeah. Okay, hold on. Present now, entire screen. Share. Okay. Okay. Can you see? Okay.
Yes, madam.
Try question number 1, okay? Try question number 1. Okay, now for question number 2, look for the figure. Okay, if you don't want to get headache with the value whatsoever, look for the figure first. Any percentage will probably it will be your P. Okay, now you are looking for N. If 20 Malaysian adults are selected, okay, if 20, okay, definitely this will be your N. Okay, find the probability that less than, okay, probability that less than 12 will say they have never heard of IoT. So this will be your keyword for your X. Okay, so in this case, X will be the number of Malaysian adult who have never heard of IoT. And definitely X is binomially distributed with 20 number of trial and probability of success is 0.55. Okay, 0.55. And definitely we know we cannot refer to our binomial table. Now we transform that. Transform as usual. We use X, we use Y. Y is binomially distributed. Number of trial maintained. God, my God. The faster I want to be. Okay, 20 number of trial. Now the probability of success become 1 minus 0.55. This will be 0.45. Now the question is find probability of X less than 12, less than 12. So transform this to probability of Y. If less than, it becomes greater than. Then 12, it will be 20 minus 12. Remaining will be what? 8, right? Okay. Do you understand that? Okay. Let me just... here is 20 minus 12. Okay, so you will get this one. Okay, now as usual from this it will be easy. I have understood how we can solve this. So this will be, we have from 0 until 20. If we are talking about 7, 8, 9, we are talking about 8, but not 8 is not included. Greater than 8. So next to 8 is 9. So greater than 8, definitely 9 will be included. So we are talking about this region, the probability value that we are looking for. So the whole probability here is 1. So definitely it will be 1 minus px is, now we are talking about from 9, then 8 will be included in your calculation, less than or equal to 8. So if you refer to your table, now refer to your table, can you give me the value of by using N20, number of trial number of trial 20, probability of success is 0.545. What is your px less than or equal to 8? Can someone give me the value? N20, P 0.45, look for 8. 8. Someone? What is the value?
4143.
Okay, 4143. Thank you. And if you deduct this, you will get 0.5857. So how do we interpret? So there is, this will be 58, just approximate directly, 59%. There is 59% chance that less than 12 will say, directly just copy the sentence in the question just now, will say, or you can say, if you wish to write 12 nation, that less than 12 nation adults have never heard about IoT. So there is 59% chance that less than 12 nation adults will have never heard about IoT. Okay, everyone. Okay, I hope you can try the first questions. Okay, so more or less the same concept. Just remember, okay, whenever you got your distribution, okay, write down your equations, transform that. First, transform your new distribution, then transform the equations. Remember, when you transform the equation, the component inside will be changed. Here will be changed. The one in circle is the one that should be changed. Okay, so the rest are almost the same, following what given in your equations. Okay, I hope you know equations. Okay, now should you, okay, now the rate histogram that you have on page 53 is just actually wanted to say that if your n, okay, increases, okay, and if your p is too small, see, if your n maintain 10 and your probability of success is 0.2, okay, if this probability of success increases in value, what happens? The graph will change into almost look like symmetric distribution. And if you increase further the probability of success, it becomes skewed to the left. When you have too small, it's skewed to the right. When you have too large, it's skewed to the left. Okay, this one is change in P. This one change in N. Okay, what happened is that if you change the value of trial into 30, so what happened? It becomes almost like symmetric. But if your N is large enough, and it becomes symmetric. Okay, so that will be talking about the effect of changes in N and changes in P. That's it. Finish with binomial. Okay, now I wish I can just quickly go through into all. I don't want to pause. Okay. Okay, class. Do you need to stop here or do you want me to continue with poisson? Class. Class. Continue with poisson or what? Because we have 20 more minutes.
Up to you, madam.
Apa dia? Tak dengar.
Up to you.
Up to me. Up to me is for you only. What about the rest? At least two, three
Up to you,
students.
madam.
Oh, up to me. Okay, up to me. I hope since we are recording this, okay, because my target is just to finish the poisson. Okay, the poisson is a bit easy compared to binomial. Okay, hopefully I can put it easy to you. Okay, now we have done with binomial. Done. Now we are talking about poisson. Now, poisson is actually simpler than binomial because the criteria, because the parameter that we are talking about poisson is only involving one value. Okay. Now, what is poisson probability distribution? Okay. So, unlike binomial, we need to check the 4 criteria. Okay, so the 4 criteria should be met. Okay, what about poisson? Okay, the difference between binomial and poisson is that we are still talking about exact value. Like binomial, x can be from 0 until 0, 1, 2 until let's say 20. Still exact value. What about poisson? Poisson also the same. We are still talking about exact value. X can be from 0 until any value. Okay, until any values. Let's say n, any values. Okay, so what about this poisson that is different? Okay, a poisson process has the following characteristic. The experiment consists of counting. So again, if we are talking about binomial, it's the number of what? If we are talking about poisson, okay, x will be also the number. Okay, the number in addition to binomial, poisson the last part will be the interval that involved. What is interval? Okay, let us see. The experiment consists of counting the number of occurrences of an event over some interval. What kind of interval? It could be time, it could be area, it could be volume, the one that we have discussed before. Okay, distance and other type of measurement. Okay, means that binomial, we just say the number of blah 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 blah, then finish. But for poisson, it's the number of what in 10 minutes, for example, in 12 kilometer, in 1 meter, for example. So that would be the interval that I mentioned just now. Okay, the number of occurrences of in one interval must be independent of other intervals. So let's say if we are talking about what we call distance. Okay, so if let's say we are talking about distance, 1 km, 0 km, 1 km, 2 km, 3 km. So if we are talking about the number, let's say the number that involved from year to year is, let's say, 10 buses pass through the number of bus cannot lah, not suitable. The number of lubang dalam bahasa Inggeris apa, lubang atas jalan tu apa nama dia? Hole lah. Can we say the number of hole? Is it pothole or hole? Class, lubang. Is it pothole? Class? I write here lah, lubang. Say, let's say you are working with the class liner, okay? Within 1 kilometer, beginning from the point that you measure until you achieve the 1 kilometer, you are going to what we call calculate the number of pothole. Okay, if you are talking about the pothole in 1 kilometer 10, so the rest also 10. This is what we call must be independent, and then pothole here and pothole here is not dependent on each other, but the number in terms of interval will be the same. Okay, no limit in the number of occurrences, so it will stop until whatever value that you have. probability of each event occurring is the same for each interval. So event for here, probability for x here is equal to probability of x here. Okay. Average number of occurrences in interval is known. Okay. Just let us understood this way. Okay. Now, what else kind of example that you may have? The number of car accidents during a month. So see, this is your x. X is equal to the number of car accident. In what interval? In a month. The number of major defect in a particular 3 miles. So this is your interval. So let's say I highlight. This is your interval. This is your interval. The number of website visitor in 30 seconds. Number of patient between 9 to 12. Number of plant growing per acre. Okay, so this is how the few example of x that following poisson. Okay, if in binomial, we know that we can have x binomially distributed with the number of parameter, number of trial, and probability of success p. What about the poisson? Okay, poisson as simple as x is following poisson with the parameter lambda. Okay, for binomial, mean or mu, okay, E or expected of x, these are all the same, meaning mean of x is NP. Variance of x is NPQ. Standard deviation of x is equal to square root of NPQ. What about lambda? Lambda is the easiest one. Okay, the mean equal to the variance, which is the mean is equal to the variance, that is sigma squared. Okay, what is that? Because since the parameter is lambda, so the mean is lambda, the variance also is the lambda. It's just that the standard deviation, okay, standard deviation would be square root of lambda. As simple as that. So if I have my binomial, okay, my binomial probability exactly equal to x is actually NCX, P to the power of x, Q to the power of n minus x. What about lambda? Lambda, okay, P of x is equal to x is equal to exponent to the power of negative lambda, lambda to the power of x divided by x factorial. Okay, so this is your formula of finding your exact probability. Okay, exact probability. Okay, plus that is as simple as the simplest of poisson. Now, are you all okay, class? Are you all okay? Hopefully okay. Now, let us look at the example. Suppose that the average number of cars arriving in 15 minutes period time is 10 cars. Find the probability that exactly 5 arrivals in 15 minutes. Now, how do I differentiate binomial equations and Poisson equations? Okay, in Poisson, the simplest way to identify is the interval. So find anywhere in your equations, if there is interval included, definitely you are talking about Poisson. Okay, but somehow, sometimes it will be a bit confusing, whereas but sometimes it will be given not to purposely give you confusion, but never mind lah. I'll just go into this one. Okay, the easiest way to identify Poisson is the time interval or the interval given in your equation. So in this case, we are talking about the interval of 15 minutes period of time. Okay, so suppose that the average number of car arriving in 15 minutes period time is 10. Okay, so we are talking about what? X is the number of what? The number of cars arriving in 15 minutes time. Okay, so in 15 minute time we know 10 cars. So X is Poisson distributed with Poisson and how many lambda? So this is your lambda. So you have 10. Okay, so you have got your X defined and you have your distribution of your X. That will be Poisson with lambda 10. Okay, now how are we going to solve this? What is the question? Find the probability that exactly 5. So from here, find the probability exactly 5. Okay, so if you look at your Poisson table, find lambda and find your lambda that is equal to 10. 10 here. We know we are talking about 5. Okay, and we know that this one is Px less than or equal to 5. In order to find exactly 5, we have to deduct with the previous, that is Px less than or equal to 4. So in this case, 0.0671 minus 0.0293. So if you deduct this, you will get what? You will get 0.0378. Or if you want to use your formula, Px is equal to 5 is equal to e to the power of negative lambda. That will be 10 lambda 10 to the power of x. X will be 5 divided by 5 factorial. Can you do that calculation, class? So definitely, as given in your textbook, it will be 0.0378. Now, class, any questions so far? For the Excel, you can try on your own. For the Excel, I'm not going to do that for you. Or am I have prepared something for you? Okay, no. Okay, using Excel. Okay. So any questions so far, class, for Poisson? Now let us do the exercise. Any question? Any question? Okay, now there is a question. What was that?
No, madam. No, madam.
Okay, no, okay. Now, if you look at page 55, 55, the last part is using Excel, right? The last part is using Excel. From the same example, by using Excel output calculate. Do you want to do the question on page 56? Never mind lah, because we have 5 minutes. So why don't we do exercise 2.4? Okay, exercise 2.4. This is interesting because now, as I mentioned earlier, if we are talking about the interval, okay? Now, the interesting part about Poisson is that sometimes the question given to you is in terms of 15 minutes. Okay, now minutes, M-I-N-U-T-E-S. Okay, 15 minutes. Now this one means that this is for 15 minutes. Now, what interesting about Poisson is that we may ask you, instead of within 15 minutes, the next question would be in 5 minutes. So what happens if the question refers to the same situation, but now the interval changed from 15 minutes to 5 minutes. So this is what happened. in your exercise 2.4. Now let us look at 2.4 before we stop. Okay, exercise 2.4. Now, phone calls arrive at the rate of 48 per hour at the reservation desk for regional airways. Find the probability of receiving 3 calls in a 5 minutes time. See, you are given in hour and the question asks you in 5 minutes. So this is usually how we give you question for poisson. So it's just the matter of how you can change from hour to minutes. So let us see how we can change the interval from hour to minutes. Of course, before you can do that, you will start with defining your x. So in this case, what will be your x? So x will be the number. The number of what? The number of phone calls. Okay, the number of phone calls at the reservation desk for, if you want to follow, for regional airways. Okay, then definitely looking at the interval, we know that this is following poisson. Now the value given to you is 48, but 48 is for 1 hour. Now if we are talking about minutes, 1 hour is equal to 60 minutes. So how do we change to minutes? So we know that we have 48 for 1 hour. So what about 5 minutes? So 5 minutes will be 1 over 48 multiply with 5. Right? Saya salah ni. Ya, sorry. Tersilap ni. 1 hour. Talking about minutes, 48 hours is for 60 minutes. Now, I'm looking for 5 minutes, then 60. Okay, salah. Okay, now what will be for 5? So it will be, let me do the calculation here. It will be poisson 48 over 60 times 5 minutes. Okay, so in this case, you will get your new distribution x following poisson. What do you get here for 5 minutes? 4, right? Correct, right? 48 over 60 multiplied by 5. Okay, so you get 4. Okay, now by using the new, which is this one is referring to 5 minutes. So don't get confused or don't get mixed up. I have 48 for 1 hour, then I have 4 for 5 minutes. 4 multiplied by how many? You can multiply by never mind lah. You just do on your own. Okay. Now let us go straight to the question. Okay. Find the probability of receiving 3 calls in a 5 minutes. So P X exactly 3 in 5 minutes. So using this, okay, X is equal to 3. Then look for lambda 4 and X is equal to 3. That will be this one. So this will be Px less than or equal to 3 minus Px less than or equal to 2 next to the value. So this will be, okay, 0.4335 minus 0.2381. So you will get 0.1954. Or it will be 19.5%. So how do you interpret? There is, you can say there is 20% chance that exactly 3 phone calls will be received in 5 minutes. So this is how we interpret. Okay? Or we can say that it is unlikely, or you can say unlikely that exactly 3 phone calls will be received in 5 minutes. What about question number 2? Okay, question number 2. Why do we do it here? Question number 2. Probability of receiving exactly 10 calls in 15 minutes. Just now in 5 minutes. Now you need to find for 15 minutes. So for 15 minutes, definitely you multiply by 3. Okay, so you will have X poisson. The moment you have new interval, find your new distribution. So in this case, lambda will be 3 multiplied by 4, you will get 12. So for lambda equal to 12, okay, so here is the B. Okay. So for lambda is equal to 12, 10 calls, exactly 10 calls. So these are following P0, 3 multiplied by 4. So you will get X poisson 12. Okay. So for 15 minutes. Okay, so exactly equal to 10 means that Px less than or equal to 10 minus Px less than or equal to 9. So for 12, you are looking for 10. 10, this one, 0.3472 minus 9, 0.2424, you will get 0.1048. Okay, so 10.5%. So you can say there is, or if we don't make the approximation, for it is just 10%, right? There is 10% chance that exactly 10 calls will be received in 15 minutes. Okay, so that would be the second question. Okay, the first, question B, Roman. Okay, so I guess I will stop here. Before we stop, do you have any more question to ask before we stop? Class?
Madam, attendance how?
It's okay. Google Meet will record the attendance. Stop here.
Okay, Doctor.
What was that? Apa dia tadi?